Alright, the lesson today, we are actually going to look at quadratic functions. A little bit of revision for you. Now, we've been through what a basic parabola is, which is y equals to x squared. And you know that it has an axis of symmetry, a turning point or a vertex, x-intercept, and y-intercept. Alright, that's at the origin. That's a basic parabola. Now, the most important thing for you to know is the basic parabola y equals to x squared, we can translate it left and right, up and down, or you can dilate it. Alright? So for y equals to ax squared plus bx plus c, which is a general form of a parabola, you must remember there could potentially be one root, two roots, or no root at all. Alright? So the root is actually the x-intercept. Please remember that. Now, this is actually a summary of what you should have learned last semester, or last term actually. The general form, the turning point form, and the root form of a quadratic equation. You know for the general form what the axis of symmetry is, and then for the turning point form, you can actually find the turning point and the axis of symmetry by going through the equation. And the root form, you need to work out the axis of symmetry. Now, I'll leave you actually to read this yourself rather than going through it. For graphing or sketching a quadratic function, you must remember the 5 things. Important one, concavity, concave up or concave down. So for concavity, what I like to do is use the word concave up, the U shape, or concave down as the N shape. So concave up here, if it is a U shape, it looks something like this. Concave down, the N shape, it looks something like this. Alright? So there is the axis of symmetry, the turning point or the vertex, the y-intercept. Remember, only one y-intercept, and there could be 2, 1, or 0 intercepts. Key features of the quadratic function, the shape, the concavity. So you've got y equals to a x squared plus bx plus c. If it is plus a, it is concave up, which is what I call the U shape. And then if it is minus a is concave down, which I call the N shape. Alright, so important to know the negative and positive. Then you know the axis of symmetry, the x-intercepts, which are also called the roots, y-intercept, and then the turning point. With that, you should be able to sketch the parabola. Now, let's do this. I would like you to sketch y equals x squared plus 2x minus 8. Here, you could, if you want, pause the video for a while and actually work this out. I'm just going to show you very quickly. Here, y, we can actually factorize it into this form, x. So two numbers which multiplies as minus 8 and adds up to 2 is 4 plus 4 and minus 2. Alright, so from here we know that the shape is concave up. You don't actually have to write that one down because when you sketch it, you know that it's a concave up shape. And then you know the y-intercept is actually when x equals to 0, 0 minus 8, read from the general form. And then for the x-intercept is when y equals to 0. So solve using null factor law to solve it. X equals to minus 4 or plus 2. Alright, so here the x-intercepts will be minus 4, 0, and 2, 0. Okay, and then the next bit, we need to know the axis of symmetry. X is equal to minus 4 plus 2 divided by 2, which is minus 1, x equals to minus 1. And therefore, substituting that to find the turning point, which is y equals to minus 1 plus 4 minus 1 minus 2, which means that is 3 times minus 3, which is minus 9. All right, so the turning point will be minus 1 and minus 9. All right, I use this format, x plus 4 and x minus 2, to work out the turning point when I substitute x equals to minus 1 in there. It's just that it will save me from looking up squares and stuff like that. So now you know the shape, you know the y-intercept, x-intercept, axis of symmetry, and turning point. We can actually sketch it. All right. Now, in the test, you're normally given the axis anyway. If not, you should be able to draw it. Remember, use a ruler. Always use a ruler. Sometimes for iPad it's harder for me to use ruler, so I do it by freehand. But this time I actually got a guide of a ruler. I'm going to start off with the axis of symmetry, x equals to minus 1. So I will just do a dotted line and label it as x equals to minus 1. And then you know that y-intercept is 0, minus 8, and so on and so forth. However, the trick is I'm actually going to sketch the parabola before I actually indicate all the points. Sometimes it just makes life a little bit easier, that's all. Remember the arrow? So now I have actually sketched the parabola. Let me put a dot there. Now I can indicate all the points. So here, this is the turning point, which is minus 1, minus 9. This point here is 0, minus 8, that's y-intercept. So this point here is 2, 0, and this point here is minus 4, 0. All right, it's this point. All right, let's change this, make sure that it is clearer. 2, 0. All right, of course, you label it y equals to x squared plus 2x minus 8. All right, so this is it. Next, what we have done before, x squared plus 2x minus 8. You know you factorize it. So the difference in this case now is the turning point, which is minus 1, minus 18. The y-axis intercept or y-intercept is 0, minus 16. Let's sketch it first. All right. So I'm taking the cheating way so that I can just label this 0, minus 16. And this is, the black line is y equals to 2x squared plus 4x minus 16. All right, so you've sketched one of them. Next one, so this time I'm going to start off with this. This is minus 1, minus 4.5. All right, so sketching it is wider. So that point here is 0, minus 4. All right, and this is y equals to x squared over 2 plus x minus 4. Bingo. All right, what I want you to get out of here is when you've got a variation of one quadratic equation, you can see that by putting in the dilation factor, you either make the parabola wider or narrower, and the change is the turning point. The x-intercept, there's no change. The axis of symmetry, there's no change. The change is, like I said, the turning point and the y-intercept. All right? Now, you got the next question. Hence, It's quite important, this word hence. Sketch y equals to 2x squared plus 4x minus 16, and y equals to x squared over 2 plus, actually, this should be x minus 4. Alright, so here the word hence, like I say, is very important because it's telling me that it's related to the previous question. Alright, let's start with the first one. Y equals to 2x squared plus 4x minus 16. Factorize it by taking out the 2, highest common factor, x squared plus 2x minus 8. Alright, is this now familiar? This bit here is actually basically the same as here. We can rewrite it as 2 x minus 4, x plus 4, x minus 2. Right. So, for an aside here, no change in x-intercept and axis of symmetry. Alright? From the null factor law, you know that x equals to minus 4 and x equals to plus 2. So the only change is the y-intercept. Y-intercept is actually 0 minus 16. Actually, it's not the only change. There's another change. The shape will be narrower since the 2 is a dilation factor, so it will be narrower. And the turning point will change. The turning point, when we work out the turning point, we don't actually even have to substitute the equation into here. We know that, again, I'm doing on the side, we know that when x is minus 1, which is the axis of symmetry, x plus 4 times x minus 2 equals to minus 9 previously. So therefore, the turning point is actually 2 times minus y. The turning point would be minus 1 minus 18, because minus 9 times 2 is minus 18. So let's go back and sketch this graph. How about let's do this. Y equals to x squared over 2 plus x minus 4. So if I take the half out, you see that this is x squared plus 2x minus 8. Again, this bit is familiar. So therefore, you know this is half x plus 4, x minus 2. Without even doing any calculation, you know that the y-intercept is 0 minus 4. And then the turning point will now be minus 1 minus 4.5, because it's half of 9. So therefore, there's no change in x-intercept and axis of symmetry. Let's go back and sketch. Here, you are asked to sketch y equals to minus x squared minus 2x plus 6. Of course, what you need to do is factorize it by taking out the common factor first. So take out the minus 1, we've got x squared plus 2x minus 6. Alright, important thing, you can see that this bit here, you cannot factorize into something with 2 roots, which means something with integer. So what I need to do is complete the square in this case. Becomes minus x squared plus 2x plus 2 divided by 2 square. 2 divided by 2 is 1. 1 square is 1. Minus 1 minus 6. Alright, that becomes minus, I'll use a square bracket now, x plus 1 all square. Alright, this is x plus 1 all square minus 7. Alright, minus 1 minus 6 is minus 7. Now, this one here is not quite the turning point form yet. What I want to do is bring it back to turning point form by multiplying the minus into the square bracket. Therefore, I have got minus, oops, I want to use a red color, minus x plus 1 all square, minus times minus is plus 7. Alright, so what I've done here is rearrange the general form into a turning point form. So you know that the turning point is actually minus 1 plus 7. And you also know that the axis of symmetry is x equals to 1. Alright? Now, the next thing you need to work out is the x-intercept. Here, for the y-intercept, read it from the general form of the equation. Y-intercept, oops, I want y-intercept. Oh. Is actually 0, 6. You know that from the general form of the equation. So here, for the x-intercept, we need to know that y is actually 0. So for x-intercept, y equals to 0. So therefore 0 equals to minus x plus 1 square plus 7. So x plus 1 square equals to 7. X plus 1 equals 2 plus or minus square root of 7. X therefore equals to 1 plus or minus square root of 7. And therefore the roots would be 1 plus square root of 7, 0. And 1 minus square root of 7, 0. Right. Sketching the graph. Sketching the graph, I'm actually just using a ruler to guide me with a bit more, looks a little bit better with a straight line. Of course, you need to do it in the exam or the test. Alright, so here you know that this is actually a concave down shape because there's a minus in front. So start off with the axis of symmetry. Y is actually minus 1. Oops, my fault. There should be a minus 1. Alright. So axis of symmetry, x equals to minus 1. I use a green color. X equals to minus 1. Alright. Now, turning point is 1 plus 7. And 0, 6. So turning point, let's say 1, 7. And then we know that 1 minus square root of 7 is on the negative side of the parabola, and 1 plus square root of 7 is on the positive side of the parabola. Alright, so actually, my fault, it should have been minus 1. That should be minus 1. Alright, so here, let's do it. Alright, square root of 7 is between 2 and 3. So 2 and 3 is greater than minus 1. So it's on, this point is on the, positive side of the axis. So if I sketch that, oops. Alright, so this is y equals to minus x squared minus 2x plus 6. Here, this point is actually minus 1 plus square root of 7, 0. This point will be minus 1 minus square root of 7, 0. Alright, so then we know this point the intercept would be 0, 6. All right? Everything looks right because it's a concave down shape, so you know there's a maximum turning point. Here we've already complete the square. Go back. So this time this is 1 minus 1 plus 14, which means this one should be minus 1. Did not label it correctly. So here there's no change in the two x-intercept, but it's narrower. Alright, so therefore this is y equals to 2 minus 2x squared minus 4x plus 12. Alright, nothing much change except the shape narrower and also turning point, and the turning point and the y-intercept here is 0, 12. Alright, okay. Now, the next one, straight away, you can see that plot the graph. So starting from here, this is half of it, and you know that it's wider. All right, there's no change in the x-axis intercept. So here is minus 1, 3.5, and that point here is 0, 3. All right, and label it y equals to minus x squared over 2 minus x plus 3. That's all you need to do. Again, make sure that you know one is double, one is half. Graph. So for f, you know that the maximum number is, for the range, the maximum number is plus 14. Again, you see this question, hence. All right, hence. So you know that it's related to the previous question. Fx or y equals to minus 2x squared minus 4x plus 2. All right, I'm just going to quickly show you one of them. So let's have a look at what I need to do here. So fx minus 2x squared minus 4x plus 12. This time, I will take the minus 2 out. All right, it's x squared minus 4x. Oh, actually, it's 2x. Oh, let's do it properly. 2x is actually plus 2x minus 6. All right. Now, you have actually completed the square here. It's x plus 1 square minus 7. Again, multiply the minus 2 in. I've got minus 2, x plus 1 square minus, it's actually plus 14 now. All right, so the change is the turning point. The turning point here is minus 1 plus 14. All right, and then the axis of symmetry, there's no change, is x equals to minus 1. Is x equals to minus 1. The y-intercept is actually now 0 plus 2. The x-intercept in this case does not change at all. Why? Let me show you. All right, the x-intercept is when y equals to 0, minus 2, x plus 1 square plus 14 equals to 0. So I can either divide everything by minus 2 first, or I can write it out this way, minus 2, x plus 1 square equals to minus 14, x plus 1 all square equals to 7, x plus 1 equals to plus or minus 7, square root of 7, x equals to minus 1 plus or minus square root of 7. No change. So again, the change is turning point, the y-intercept, and of course the shape in this case is narrower. Let's sketch it. Alright, because I've halved everything. Alright, this one I have halved everything. So therefore, straight away for fx, or gx actually, equals to minus x squared over 2 minus x plus 3 is actually minus half x squared plus 2x minus 6. Alright, therefore the turning point here is minus 1, and this time will be the turning point is minus 1 and 3.5. Alright, or 3.5, which is half of the previous one, and the change is the intercept, the y-intercept, which is now y-intercept is now actually 0, 3. Alright, go back. So next one, what I need to do is write down the domain and range. So in our case, let's do just one, fx. Alright, so the domain of f, alright, which is the domain of function f, is actually x is such that x is in the real, is an element of the real number, and in fact, because x is from negative infinity to plus infinity, that's all I need to say. So x is in the range of x, domain of x. X is an element of a real number. And let's go back to have a look at. So here, so the range of f is equals to fx is such that fx is an element of the real number, and fx is less than or equals to 14. Alright, so for gx, so the domain of g, which is gx, is such that again x is a member of the real number, element of the real number, and the range of g is gx. Gx is an element of the real number, and then this time gx is less than or equals to 3.5. Alright, that's all you need to write. Now, this one I'm actually looking at what I've asked you to do in your last week of term 1, which is application of the quadratic function. You must know how to use your class pad. It will save your time spent on this question. What you need to do is plot this equation using your class pad. Alright? Use your class pad. Use class pad. And then in order to find the maximum height, use gsolve. Alright? Again, use gsolve. Right? So important, use class pad. Once you draw it, use gsolve, and then once you find the maximum, divide it by 2. Then you can find the answer for the width of each lane. And finally, when you are asked to work out whether the bars will fit in, what you need to do is again use analysis. Is x cal / y cal. Alright, what you want in this case is you want the x cal, because you want to see whether the bars can fit. You know, if you draw the bars, sketch the bars on here. Okay, once you get that, alright. This is the side of the bars which needs to fit into the tunnel. So that is the width of the bars, and you can see that no, it doesn't fit because in one lane, because it's actually when you add in the width of the bars, is actually bigger than the single lane. All right, that's end of the lesson.